Hi, Asia.
Good evening, sir.
How are you?
Not bad. How are you?
I'm giving thanks. Let me ask you, how is your, how are the preparations going to?
Um, for now, I'm just trying to finish up Edicasa.
Okay, cool. Um, are you still revising the areas that we've gone through? Remember, I tell you that correlation coefficient is a must-have.
Yes, sir.
Measures of measures of central tendency is a must-have. So I want you to go through all that probability distribution is also a must. So everything that we've gone through so far, if I were to stop teaching now, you should be able to enter the exam and pass it. So I want you to be able to go and remember those stuff. I don't want you to go into the exam and try to remember the formulas and can't remember the formulas because you won't be given any formula sheet in the exam. So I want you to be able to commit them to memory. And that's why I did those topics up front. The other little topics that are left are like some 5 marks and 10 marks. The ones that I did up front are plenty marks. So I got those out of the way. So I'm expecting that you guys will go through those just to make sure that you are comfortable doing them and you remember the formula. So I depend on your money to just commit those formulations, to find the least squared regression, to find you know, the correlation coefficient, to find the midpoint, to find the whole stuff that we've done. Commit those to memory because they're not going to get a formula sheet in the exam. So I was going to get a formula sheet that I say, which is which. So I depend on you to do what it is that you need to do so that you can come out on top. That's okay?
Of course, sir. Of course.
Good. Um, I'm speaking to one of your lecturers and, got pretty much some very good reviews of the class. So, I think your lecturers are also expecting big things. All right. Lord Jesus, this is night 7:39. All right, let me get the others another 5 minutes now. And then if not, if by quarter to eight they don't turn up, we're going to start. Right?
Okay, sir.
Class now start with it and our system act upon me. I was saying that I'm gonna give the others another 5 minutes to come in, failure to that, you never just start. All right?
Yes, sir.
soon we are going to be together. All right. Come on, Joe. Oh. Asia,
Yes, sir.
um, the the computer went right. This one please in the meantime, so that I can. Anytime I'm using this computer, I have to log on into to two devices because it just has a way of just going. And it's a good thing that I did it because it went. So I'm trying to get back into it. Write this for me, please. Seeds have a probability of germinating of 0.9. Seeds, I'm going to type it nonetheless, but until this comes up, we can start working on it for me, please. It's a question again on the binomial distribution, like what we did. So this is just a refresher before we move into something else. So seeds have a probability of germinating of 0.9. Seeds have a probability of germinating of 0.9. Full stop. If six seeds are sown, if 6 seeds are sown, what is the probability? What is the probability of 5 or more seeds germinating? If 6 seeds are sown, what is the probability of 5 or more seeds germinating? All right, start on that for me, please. I'm gonna type it as soon as the system comes up. So this is very similar to the remember the probability distribution question I got, and I introduced it to recombination notation.
Yes, sir.
Right. This is very similar to it. So start that for me, please. How are you going? Are you moving all right?
Sir, I'm lost. Of me blank.
You're, you're lost?
Mm-hmm.
You're blank? What's the probability of it occurring? Are you hearing me?
Sir, can I break it up? Can you repeat, please?
Now I was asking, what is the probability of it occurring?
Based on what I did, I got 0.531.
No, what is the probability of it occurring?
So I don't understand the question.
All right, so hold on. So what I'm saying is that maybe when I show it like this, you'll see. So seeds have a probability of germinating of 0.9. What is the probability of it germinating?
0.9.
What's the probability of it not germinating?
0.1.
Excellent. Excellent. So the question on probability distribution speaks of only two possibilities. Remember I was saying to you last time, the probability distribution talks about A plus B raised to N. It's only two possibilities it speaks of. Only two possibilities. One is success, the other is failure. So one is success, the other is failure. So anytime you see how you're able to identify the probability, the binomial distribution, it speaks of exactly two possibilities. One is going to be success, one is going to be failure. So if you look back at the question that we did the last time, something another was 0.7. You remember that one?
Sir, sure, was that class that day? Last class.
It wasn't last class that we
Um, let me go back to.
because
Sir, not hearing you.
I don't remember the question that I gave you, but it was. Are you hear me
Yes,
now?
sir, hearing.
Yeah. It was a question that we did where look in a WhatsApp group and see if you because I actually sent over the stuff. Let me look in a WhatsApp group because Paz reminded me that I didn't send the. I don't like it coming today.
The last thing I'm seeing is one with an angle and with the 100 balls. That's the last one I'm seeing.
Um, what the book was in? All right, the one that I sent on April 11th at 12:04 p.m. It says N was 7. Oh, the rainfall. I said that the probability of it raining one day for the week is 0.3. You remember that one?
So I don't think I was there that day.
Don't worry about it. Don't worry about it. If you weren't here, don't worry about it. So, okay. So, great. It's a good thing then that I am doing a revision so that at least you can catch up on something that you would have missed. Not a problem. So let us go. So the others can listen to the recording and get this stuff. All right, let me just finish typing the question. If 6 seeds are sown, what is the probability? What is the probability of 5 or more seeds germinating? All right, so that's the question. So the question says, seeds have a probability of germinating of 0.5 or 0.9. If 6 seeds are sown, what is the probability of 5 or more seeds germinating? Now, we're using the binomial distribution. Why? Because any situation having only two possibility that are mutually exclusive outcome, that are mutually exclusive. Talking about success or failure, we use the binomial distribution. Now you may say to me, sir, you know what the binomial distribution is from pre-calculus. That's not a problem. And that's why I'm using this computer here, because I figured that I would have to go back to some stuff here. All right, you may be seeing a blank screen because I'm trying to find let me just find something from pre-calc here on the binomials. I don't want to have to be typing, so I'm just trying to find it. So all right. So do you remember seeing that in pre-calculus as a binomial
Yes, sir.
expansion? All right. So let me just explain something here now. Binomial expansion here is saying you have exactly two events inside here, A and B. Exactly two events, A and B. All right. Now, when A give up one, B is going to accept it. So A and B is working in tandem, because look at this. This is going to be A raised to the nth power. I know what, the binomial expansion already. So what I'm doing here is just a mere review. A is raised to the nth power. A is raised to the nth power. And when A gives up one seater, A minus one, B accepts it. And when A gives up two seater, n minus two, B accepts the two. And when A gives up three, B accepts the three. So at all times, the sum of the powers is going to be equal to the overall power. At all times, the sum of the power is going to be equal to the overall power. Follow me?
Yes, sir.
All right, good. So let us go back to this now. It says seeds have a probability of germinating of 0.9. So I'm saying to you here, the binomial situation is going to be used when you have only two possible mutually exclusive events occurring. So if you want, I can say any situation having only two possible mutually exclusive outcomes. And it is often labeled BELLED as success, SUCCESS, or failure. Is called a binomial, BINOMIALSITUA. It's called a binomial situation, right? So we know that it says seeds have a probability of germinating of 0.9. So it means that the success is going to be 0.9. The failure is going to be 0.1. Why? Because the sum of the probability is always equal to
1.
Always equals to 1, right? Now, so the truth of the matter is the solution, well, all of this here says the solution starting from here. No, I don't need to write that. The solution here is going to be n is going to be equal to 6. n is going to be equal to 6. N is equal to 6. And the probability of success is going to be equal to 0.9. Do you agree that the probability of success is 0.9?
Yes, sir.
Right, because that is you germinating the seed. Now, the probability of all right, I'm trying to type something here. Give me a half a second. 6 choose X. 6 choose X. I'm trying to type something here. Hold on a second. Oh, all right. Let me just copy that and paste it here. Check code. I'm trying to type something here for you, so just give me a half a second. I can't write on this system, but I have to use this system today because of what it is that I'm doing. So this is going to be 6 choose X, and that's a probability of 0.9 of X times 0.1 All right. So look at what I have here. So I'm saying to you, in order for me to work this question, using the same concept up here, which is why I say I was using this computer because I needed to copy this formula, or the computer can't type it. Using this formulation here, the probability of X occurring is going to be 6 because it says 6 seeds are sown. So it told me how many seeds are sown. So the maximum seeds that I'm talking about is 6. So 6 seeds are sown, and I want to find the probability of 5 or more seeds germinating. So 6 seeds are sown. This X is whatever number of seeds that I'm trying to germinate at a success rate. The probability of it occurring is going to be raised to that, and the probability of it not occurring is going to be raised to that, because the sum of the probability is supposed to be equal to the overall. The sum of the power is supposed to be equal to the overall power. Remember, the overall power is 6 because it's 6 seeds. And if I have this as X and 6 minus X, 6 minus X plus X is 6. Do you agree with that?
Yes, sir.
Good. So this is my general formula that I'm going to be using. So if I say to you now that the probability, all right, I'm just typing something here. Probability of 5 or more germinations I'm going to write greater than or equals to 5. Greater than or equals to 5. You should understand that X is greater than or equals to 5. It's going to be equal to probability of X equals 5. And let me just copy this. Look at that now. So the probability, it says, if seeds are sown, what is the probability of 5 or more? So can you agree that X here is going to be greater than or equal to 5 because I said 5 or more?
Yes, sir.
Good. So when I break out the 5 or more, now I'm going to have the probability of X here to be equal to 5. The probability of X here to be equal to 5, because it says 5 or more. So I can have 5 or I can have more than 5. So the probability of X equals 5. And then also now, I'm going to say the probability of X equals 6. Could I go again now and talk about the probability of X equals 7?
Yes, sir.
Why?
Because it says it's greater than or equal to 5.
5. Okay, but how many seeds were planted?
6 were planted.
So can I go to 7?
Oh, no, sir.
Right. So it's what I'm saying. So so I asked a question because you know where to stop. I can't go to 7 because there were only 6 seeds planted. You follow me?
Yes, sir.
Good. So it says no. So it will be the probability of me planting with a success rate of 5 plus the probability of me planting with a success rate of 6. All right. So look at what it's going to have now. So this is my equation. Look at what I'm going to have. This X here is going to be 5. Let me put that there. X is greater than or equals to 5. Let me just change that, greater than or equals to 5. And then change this to 5. Then upstairs into the 5. And then if that is 5, that has to be 1. All right, watch me now. So the probability of it being 5, you see it? This X here is it being 5 first. Do you agree that this thing sets out everything for it being at 5 first?
Yes, sir.
Good, because x is going to be 5. So if it's going to be if it's going to be 6 now, I'll have to add I'll have to add the probability of it when all 6 seeds are germinating. So let me show you what happens here. In the probability of 6 seeds germinating, how many failures do I have? If all 6 seeds germinate, how many failures do I have?
0 failure.
Very good. You understand why I have 0 failure up here, so?
Yes, sir.
Good. So what this is saying now is that the probability of me germinating all 5 seeds and the probability of me germinating all 6 seeds, because the success rate of germination, as the question says, is 0.9. That means failure rate is going to be 0.1. So when I successfully germinate, this 0.9 has to be raised to 5, because that is going to be the success rate. And this 0.1 is going to be raised to 1, because that is my failure. No, I want to calculate the probability of me successfully germinating 5 seeds. And that's why the 5 is up atop this one. Get it?
Yes, sir.
Good. And then now, because it's a combination that we're doing, we have to use the binomial here, which is going to be 6 choose 5 and 6 choose 6. Now, let me tell you, one of the things I was pointing out to the students last class when I did this, not really the last class, it was a class before when I did this. This one, okay, so there's a sequence. So if I have this 5 plus this one has to be equal to the overall power. So if you notice 5 plus 1 is equal to the overall power 6, because the 6 seeds we're talking about. I notice now that 6 plus 0 is going to be equal to 6, because that's the overall power. All right? Now, good. Take out your calculator for me, and I want you to evaluate 6 choose 5. So you're going to look at on a calculator, you're going to look for NPR and NCR. NCR is what we're going to be interested in using now. NCR is what we want to use now. Are you seeing that? Look over your 5 or your division sign if you see NCR, NPR.
Oh, yes, sir.
Okay, good. So what I want you to do is to press 6, C, 5, and tell me what you get.
6.
Very good. So 6C5 is 6. All right, you can see a black screen because, as I say, I have to use the system today because of the notes that I want to present to you are embedded here. All right, so 6 choose 5 is 6. All right, good. So I have that. So let me just write 6. What is 0.9 raised to the 5th power?
0.59049.
0.59049?
Yes, sir.
And 0.1 raised to the first power is just simply 0.1, right?
Yes, sir.
All right, what is 6 choose 6 now?
1.
All right, very good. And what is 0.9 choose 6? 0.9 raised to the 6th power?
0.531441.
0.531441?
Yes, sir.
All right, so tell me if that's what it is that you get. So 6 choose 5 is 6. 0.9 to the 5th is 0.59049. That's what you told me, right?
Yes, sir.
Good. And 0.1 to the first power is just simply 0.1. And then plus now, 6 choose 6 is 1. And 0.9 to the 6th power is going to be 0.531441. That's what I said, right?
Yes, sir.
Good. And of course, anything raised to the power 0 is 1. All right? Now multiply for me 6 times 0.59049 until what you get.
3.54294.
times 0.1. Times that by 0.1 now and tell me what you get.
0.354294.
Say it again. 0.354.
0.354294.
All right. So what I want you to do now is to, 1 times that is just simply that. Simply 0.53. Look at the screen and add those two for me now, please. 0.354294 plus 0.53144. And tell me what you get.
0.885735.
0.8853.
0.885735.
All right. After the 5 comes what?
After the 2 8s, then the 5?
Yeah, well, after the 5 come what?
735.
All right, so I'm going to call it, 0.886. That would be correct if I call it that?
Yes, sir.
All right. So that is a probability of 5 or more seeds germinating. That's a probability of 5 or more seeds generating.
Oui.
So let us look at the question again. Let us look through the question again. You weren't here the last time, so I'm taking some little time to go through this with you. All right, so let us look at this one again. So it says, so the question is, seeds have a probability of germinating of 0.9. So if seeds are sown, what is the probability of 5 or more seeds germinating? I'm going to extend this question because I really want to make sure that you get it. So we're using a binomial expansion. And what I'm saying to you is that any situation having only 2 possibilities, only 2. It can't have more than 2. Why, sir? Look on this. It's A and B, don't A plus B. So it can't have more than 2 possibilities. It has to have exactly 2 possibilities. And the possibilities must be mutually exclusive. So one is going to be labeled as success, and one is going to be failure. So you can't have a midway between. It's either right or wrong. You can't have gray. It's either black or white. You follow what I mean by mutually exclusive?
Yes, sir.
Yeah, it's either black or it's white. Can't have gray. So you can have either success or failure. Now, what I'm saying to you, n is going to be equal to 6. That's my maximum. I can't have anything greater than n. Why, sir? Because there are only 6 seeds that were planted or germinated. All right? Now, the probability of my success rate is going to be 0.9. How do I get that? Because the question copy. The question told me. The question told me. The question told me. So the probability of my failure now is going to be 0.1. Why? Because the sum of the probabilities better equals to 1. We know that the sum of the probabilities has to be equals to 1. Can't be greater than 1, can't be less than 1. The sum of the probabilities must be equal to 1. So, so my failure has to be 0.1. And then now, the probability of it occurring is going to be in that general form, 6, because the highest power is 6. And I'm going to have x, 6 choose x, and this 0.9 has to be raised to x because this x is the probability of it germinating. That's the probability of it germinating. And then now, Remember, the sum of the power is supposed to be equal to the overall power. So if this down here is x and this is x, that means I have to subtract x from this. Remember, no, look at this. Look at this. This is a to the n, b to the 0. When a loses 1, b picks it up. You follow me?
Yes, sir.
Good. So when this here gets a value, b better be the other value that will add it up to the overall power. So now we're looking at the probability of it. What the question said, the probability of 5 or more seeds germinating. We're trying to find the probability of 5 or more seeds germinating. So therefore, the probability of 5 or more germinating is going to be greater than 5 or equal to 5. So that means I can have 5 or 6. Do you understand greater than or equal to 5 means?
That it's 5 or more.
Or 5 or more. And we know we can't go to 7 because there's only 6 seeds were germinated. Follow me?
Yes, sir.
So the probability now is going to be, my calculation rather is going to be 6 choose 5, 0.9 to the 5th power, times the probability of it failing, which is going to be 0.1 to the 1st. That's when I do 5. But when I do 6 seeds, all 6 seeds, that means 6 of them going to germinate, the probability of it germinating will have to be 6. Will have to be 0.9 to the 6th power, because all of them germinated. How many failures do I have? 0. So that's why I'm going to have 0.1 to the 0. And I just showed you how we're going to calculate, or how it is that we're going to calculate it. 6 choose 5 is 6. And 0.9 to the 5th power is going to be 0.59049. And of course, 0.1 to the 1st power is simply 0.1. And 6 choose 6 is going to be 1. And 0.9 to the 6th power is going to be 0.531441. And importantly, anything raised to the power 0 is 1. So when you evaluate all of that, you'll end up with a 0.886. So that is going to be the probability of 5 or more seeds germinating. Follow me?
Yes, sir. Clear now.
All right, good. All right, I'm going to ask you to do something, and I want you to get I want to calculate the probability of I want you to calculate that. Oh crap! Sorry, I signed that is wrong. I wonder if I should do that to trick you. All right, look at that, Asia. I want you to calculate the probability. Okay, I want you to calculate the probability. Interpret this for me, please. Interpret this inequality for me, please.
That x is greater than or equal to 2, but less than 5.
What are the probabilities that we're talking about? Based on what you just read, what are the probabilities we're talking about?
2, 3, 4.
Excellent, my love. Very nice. Very, very nice. So I'm leaving this up here, and I want to calculate the probability, because it's a question like this, then can give you many parts and give you all 15 marks to it. All right? So I really want you to understand the probability, the binomial distribution. So this is another part. I am extending the question. So I want you to calculate now the probability of doing greater than or equal to 2, but less than 5. So yes, you're correct. So it's going to be the probability of 2, 3, and 4. Can you go to 5?
No, sir. Less than 5.
Less than 5. All right. So I am just going to write those and then probability of 2, probability of 3, probability of 4. All right, so look at that. So do you agree that this is what it is that we're going to be doing?
Yes, sir.
All right, go ahead and do it for me, please. You following right, Israel?
Yes, sir.
Okay, cool. You all right?
Yes, sir. Almost finished.
Okay.
Sir, is there a way to change the calculator when you're calculator and it gives time, like it gives a number times 10 to do something, something, something? Because I'm
If
trying
there's
to.
a way to what?
So if I do a number um to a power of something, it gives me the number itself and then it said times and then it gives me the
Or
the
in standard form, it gives you
yeah,
standard
standard
form.
form.
Mm-hmm.
I'm trying to do
Um,
it manually, that's why it's taking a while.
all right. So see if you can press F to D or S to D on the calculator and see if it comes off.
F to D.
Yeah. So look on the calculator, you should see what brand calculator you're using.
I guess you.
Um, they don't have it. Not you're not gonna have it.
I wonder if the phone would be different.
No, man, the phone it's gonna give you like that. All right. Read the number for me. Let me convert it for you.
Alright, so oh sorry, it gives me a differently on the phone. It gives me the
You give me
entire thing
different.
on the phone.
Okay, then. All right. Do your thing then.
Yeah. So I don't know. Don't like how big this number is right now. I got uh, 0.11421.
0.11424.
421.
All right.
The answer right.
No worries. Let us.
So we were still using the seed example, right? The seed question. This is a
Yeah,
part B too.
yeah. This is a part B. So
Right.
I'm just extending the question so you can see how how they can possibly extend the questions to you because there's another extension to the question that I want to do.
Okay.
Um,
Mhm.
actually, so it's going to be 6 2. That is actually second floor. One, three, second hole. All right. All right. So it's going to be the probability of two. Can you see how I get two? So it's still going to be six because the six C's we have, right? So it's
Yes,
going
sir.
to be two, then three, then four.
Yes, sir.
Now, six choose two is how much?
50. 6 choose 2. 50.
It's 15.
Yes, sir. That's what
I
I
want this
got.
point. All right. Let me let me let me work with my calculator instead of using what you have, just to confirm. So six choose. All right. So when you put six choose two on your calculator, you got 15, right?
Yes, sir.
All right. Good. Point nine to the second power. What you got?
So 0.81.
6 choose 3 is
20.
0.1 to the third is
0.001.
6 choose 4 is
15.
0.9 to the 4 you get
0.6561.
good. Getting that as well. And 0.1 squared is going to be 0.01. All right, so that's 15 times 0.81 times 0.1231 equals 0.0001231215 20 times 0.729 times 0.001 0.01458 plus 15 times 0.6561 times 0.01 equals 0.098 plus 0.01458 plus 0.001215. I get 0.11421.
Oh,
That's what you got?
oh, sorry.
All right, I'm going to
Oh,
put it
zero
at
point 0.1. Oh, is 0. Repeat the answer, sir.
0.11421.
Oh, yes, sir. I got that.
All right, good job. So that is the probability of having 2, but no more than 5 seeds germinating.
Oh,
It's
sorry.
so,
I
it's
thought it
so,
was
it's,
difficult.
huh?
I thought it was difficult.
No. Uh-uh. I have a last one. I have a final one to give you though.
Yes, sir.
I have a final one to give you, and I'm going to see if you're thinking about it. Um, I'm going to see if you're thinking about it. Hmm. Hmm. All right. I would say, what is the probability of
This part C are a different question.
no? This is a different one that I'm generating, but I want to. I'm trying to word it. Um, all right. My question to you is, what is the probability of X is No, I don't want us to talk about it. You may not have to, you have to do any calculation. Um, the probability of what's the probability of x is less than or equal to 4? Do you think you have to calculate that?
So I guess I'll just use it from, it's the same question, right?
It's the same question, yeah.
I'll just use what was worked out from part 2. So where it says the last one there. C choose 6 choose 4 and the 0.9 and the 0.1 at the end.
Okay, so you said that you'll use part 2.
Oh, less than or equal to. So that means is
What is x?
so less than 4 would be 1, 2, 3, 4.
Mm-hmm.
I guess you just add a 1 to it. Add probability of x equal 1 to it. So the answer you got from 2.
Do that one quickly for me. Do that one quickly for me and tell me what it is that I get out. So I want to prove a point. You will be correct if you just add the probability of 1 to this. Could I calculate the probability of 0?
Yes, sir.
How so? Because if I have 0, if I have the probability of it not up,
So it would be 6 choose 0 and then 0 at the top where 0.9 is.
and then 6 up here.
Oh,
All
yes,
right.
sir.
So that means, so I ask a question because is it just 1 that you have to do, or is you have to do 0 and 1 as well?
Yes, sir. I was wondering. I was wondering if would it be all the way to 0 or would it start at 1? That's why I
Right.
hesitated.
Good. So it will have to be 0 as well because you can have the worms eating out all of the seeds and none of them at all germinating. You follow what I'm asking?
Yes, sir.
Good. So just do those two quickly, and then I'm going to show you something very nice. With that, and then we can call it a day. It was nice
All
having class with you. But I give you 2 minutes.
right.
Work that out for me. 2 minutes. All right, Asia.
Yes, sir.
I think my point, if I'm thinking of the question properly, I think my point will be proved if we use two decimal places, but never mind. Continue working and then I'll prove or disprove my point. It should take about another minute, so we soon finish.
Mm. Yes, sir. I got 0.114751. And the two decimal place 0.11.
Was that one answer for me, Asia?
Yes, sir. I got 0.114751 and to two decimal places 0.11.
All right. Use it as 3 for me. Use it to what you got for your answer? 0.114
Yes, sir.
or is 115?
0.115, yeah. Sir, you said two decimal places.
Yeah, but what I'm saying, use it to 3 decimal places. Let me see what I get. The
Zero
answer you just
point,
got a while ago, run it off the street.
the full answer is 0.114751 and to three decimal places 0.114. 0.115, yeah.
0.115. All right. Look at the screen. Subtract this from 1 for me and tell me what to get.
0.114.
For what?
0.114.
0.114.
Sorry, you're
Oh,
breaking
that's
up.
0.114. Okay. All right. So the point I'm making is you recognize that you never had to go through all of this. You could just subtract this from 1 because
Yes, sir.
this is a probability of it occurring for 5 and 6. So the probability of it not occurring would be 0, 1, 2, 3, 4, don't?
Oh, yes, sir.
Huh?
Yes, sir. Sir, you hearing? Sir, you hearing me?
Can you see my screen, by the way?
Yes, sir. Still seeing it.
Asia? All right, good. So it's a quick question. So can you recognize that the probability of it being greater than 5 will be 5 and 6, since you have 6 seeds germinating? Do you agree with me then that if I say 1 minus the probability of it being 5 or more would have given me the answer that you just calculated without going through all of what we just did?
Oh, yes, sir.
Subtract 0.886 from 1 and you get 0.114.
Yes, sir.
Yes, no?
Yes, sir.
Right. And you recognize when you calculate when you did the probability of 0, 1, 2, 3, and 4.
Sir, you still there?
Asia, hear me?
Yes, sir. Hearing you.
Asia, hear me?
Yes, sir.
Oh Lord. Yeah, all right. In 2 seconds, I was just to finish up the thought. So what I'm saying to you, I want you to recognize, look at the screen quickly before I go again. Look at the screen. The probability of it being 5 or more,
Mhm.
if I ask you the probability of, that's the probability of it occurring. If I ask you what is the probability of it being between 0 and 4,
Mhm.
all you would have had to do was to subtract this from 1. When you subtract this from 1, you get 0.114. And when you add up all of these, then you got 0.115.
Yes, sir.
Right. So the point I'm making is you didn't have to go and physically calculate the probability of it being 0, 1, 2, 3, 4, because you already know the probability of it occurring 5 and 6. So in order for it not occurring, all you had to do is subtract it from 1, and you'd have gotten the answer quick and fast right there. So a question like that on the exam paper may have been something like 1, no more than 2 marks, and you'll be wondering to yourself, why I have to do so much calculation for only 1 or 2 marks? But what they would have expected you to do is to say 1 minus the probability. The probability of it occurring fully minus the probability of it occurring. The total probability minus the probability of it occurring is going to be equal to the probability of it not occurring, because the sum of the probabilities will be equal to 1. Success, failure. So failure is going to be 1 minus success.
Ah.
Success plus failure is equal to 1.
Yes, sir.
You follow that? Good. Big up yourself. Have a good one. I'm going to send this document at a type of so at least you can have it to reference, and for those who weren't at class tonight can have a look at it, and then you continue doing your education for me. All right?
Yes, sir. No problem. Before you go, sir. The problem
Uh-huh.
with that I'm having with the standard form thing, would I have to work it out manually in the exam since it's not working on my calculator?
All right. So yes, you'd have to, but based on what it is that I saw, well, when I did the question, you'd have gotten 1 times 10 to the negative 4. Agreed?
Yes, sir.
Good. So getting one times 10 to the negative 4 is simply you having a decimal point with 3 zeros and a 1, because
Oh.
that would be 4 decimal places. And when you got 1 times 10 to the third, it means that you'll have the decimal point, 2 zeros and a 1.
Oh, okay. Hmm.
Right. Quick question. Dave Mary still down there?
Yes, sir. Not going away.
All right. So me I try calling day before yesterday and him not answer the phone. Is hard. Me go try him tomorrow, and if him not answer, me go call you.
Call me.
Tell him to answer him phone.
Call me, sir. I don't even know me
So hold on.
exist.
So which one of them you at?
The small
Melbourne?
one. Melbourne, yes, sir.
Oh, the small one, small one. All right. All right, then that not gonna work then. Because I was gonna
Mm-hmm.
pass by there on Monday. But anyhow, big up yourself. Have a
Yeah.
good one.
Bye, sir. Thank you.
Bye bye. No problem. I'm telling you this.